Hi, I am Samuel Bamgbola and I'm an Alpha Microsoft Learn Student Ambassador. In this video, I'll be walking you through a learning path I completed on Microsoft Learn focused on machine learning operations. It is an end-to-end MLOps project-based learning path. I'll be introducing you to Azure Machine Learning Studio, and using GitHub and GitHub Actions to automate workflows and use for MLOps. A couple of weeks ago, I mentioned that I completed a learning path on Microsoft Learn. It was project based, talking about machine learning operations. So I just want to do a walkthrough of how the learning path went for me, and yeah. So the first um, module was on using Azure Machine Learning job for automation, and following the exercise which I've already opened up here. The first challenge was to convert a notebook to production code. So as we all know, training or working with your Jupyter notebook is not suitable for production or deployment. Is just good for experimentation. And in this in the directory here, we can see that the notebook is under experimentation. And then what this challenge focused on is converting this notebook into a script, a Python script. And how you do that is that you clean your code and then you convert most of your scripts, or most of your syntax and commands, and into reusable functions. So we created this function main get csvsdf. So like that, this one will read through, get the path to your file on your local machine using the path on your local machine, or you could also reference it using Azure Machine Learning. And then we created a function that splits the data and also train the model, and then the one that actually collects the variables to run these functions. So doing this actually makes your scripts reusable anywhere, and suitable for um, deployment, or suitable for what's the word, for production. So yes, also the second part of this challenge made required us to add use ML flow for auto login. So what auto login does, or what login basically does, is that whatever errors or whatever things that come up while working with your model or while running the script is shown or is saved in a text file. Like for example, on Azure Machine Learning now, running this job, for example, using the ML flow autolog, we'll be able to see the outputs of the model, whatever errors could come up. And then, okay, so you can see ML flow tracking and all that, auto logging successfully enabled and all that. So there was no issue or whatever warnings that you could see. Sometimes we see these warnings in our notebooks when training. Maybe this syntax is depreciating or stuff like that. This is what auto logging does. Your script will not show when you're running. Like we said, the notebook is good for experimentation, but when you're running your script, you don't see all those things. But then logging helps do that, and we're making use of ML flow to auto log these things. So moving on to the next challenge was to create an Azure Machine Learning job, and we're meant to do this using the Azure CLI. And for us to use Azure CLI, the method also recommended was to do this using a YAML file. right? So we defined a YAML file, but first, following the instructions, we referenced try to create our workspace and everything. These are normal things that you need to work with. Create your Azure Machine Learning workspace with the location and the create your resource group also, and then you launch the studio. And this is the studio where we are now. So going through to create a compute instance, create an Azure Machine Learning workspace and compute instance. You can do all that here. The compute instance was created, but since it was no longer in use towards the end of the project, or let me say the learning path, which was project based, was deleted. These are these is important when you're trying to manage cost, and because you don't want to add extra expenses for something that's not in use. Okay, so a compute is just like a virtual machine, right, that you can make use of on the cloud. This is with Azure now. So there are different types. You have there the standard D types. You can actually check the quota to see. So for example, let's say we try to create one now. You can see the different types that we have. So you can see standard A and so many, and with the cost per hour to run this virtual or make use of these virtual machines. So this is why it's important for you to actually stop the run of a virtual machine or delete it entirely when you are no longer making use of it. So that's why along the course of the project we had to delete the compute instance that was initially created, which because it was no longer used, and then at some point you might run out of quota, as your subscription has assigned number of cores, or um, yes, let me put it like that, assigned number of cores or maximum number of cores that you could actually make use of. So we can see here now this one makes use of 2 cores, and then by the time you know you are running, there might be a need to request for more cores and all that. So it's always good to delete or stop, in fact delete every compute that is no longer in use during the course of any project you might be working on. So creating the data assets here, you can do this from here, and then we have this diabetes dev folder data sets here. We can check out how the data set looks like from the explore page. So we did all that, created the YAML file, and this is what the YAML file looks like. So it's kind of encapsulates everything that you do manually into a file, and then this file is run and it automates it. So instead of you typing into your command line, running all these commands, it does that, and it references the input, so where the data is, which is already uploaded here. So we can see from here we can actually get the path to the data set referencing Azure, using Azure, where it's stored in the Azure ML Studio. The data set's called data assets. So it's referenced here, and then from this input of diabetes, we can see that it gets through and it's referenced here, the path to it. And then the environment basically just means your workspace, or just like when you create a virtual environment while working on a project, and you've installed all the dependencies. So this environment just represents a virtual environment, or a virtual, yeah, let me put it that way, a virtual environment that has all the dependencies that you need for this particular script to run to train your model. So we already created our computer and we added the path to it, the experiment name, and the description. So that was it for that particular task there. And then we ran the job using Azure CLI. So I stored most of the things I used to all the Azure CLI syntax I used, because I was new to it. I actually had to take another learning path to learn that. There's a learning path, okay, learn how to use Azure CLI with how to use CLI with Azure Machine Learning. So it's also a learning path that you might have to take while also working on this uh, the main learning part of the machine MLOps project. So we use this syntax to create the job, or to run the job, and then running the job gives you something like this. So you have this was the first one that was completed, so this is it. You can check the metrics of your training set and training accuracy, because this is a classification model predicting whether a patient is diabetic. And then we could check some other things, confusion matrix, then the ROC curve, for measuring the accuracy and other things, the precision recall curve, and any other thing that you might need is also referenced. The script is also referenced here, which was used to train. And then yes, so this is all the other parameters that were used for the model, like the hyperparameters that were used, is also stored here, though we use the default. The reg rate was the only thing that was imputed, so every other thing apart from that is the default values uh, given by the linear regression model from scikit-learn. So moving on to the next challenge, the trigger Azure Machine Learning job with GitHub. So this is where the automation work really started. And then moving to scripts, now we had this. All these were stored on GitHub, all the scripts, because at the end we had to use GitHub Actions to automate some workflows. But first starting with this triggering the machine learning job, which we just did now with this script. With this, running this on the terminal. And one way to access this is you have for Visual Studio Code, you can access the Azure Cloud, which is also a Microsoft service. You can access the Azure cloud from here. So you use your AZ login. It's also an Azure syntax. AZ login to log into your subscription or to your Azure account, and then once you do that, mine is already logged in already. You could see my account here, but though sometimes you still need to log in through the terminal so that it can be accessed. Or I won't call it the terminal now, it's called the cloud shell as regards Azure. So once you do this, we run the script with it and it runs. So now what we are trying to do now, to use GitHub to automate this, or not, I won't say automate, but then to trigger the running of the job with GitHub Actions. So we have this script here, and this is the syntax that we can use to create this. So they're like steps and everything followed. This was used so we can see manually trigger this on workflow dispatch. So what workflow dispatch means is that you are manually triggering it, not automated. If we check other ones, this one is triggering a GitHub Actions workflow too with pull request. So this is on request. So all these have different meanings, and this is just the same thing like the command that will be run if it were to be done manually, but then it is automating it. You have to create an environment in GitHub to that will have access, that will just use, this will be used to log in. As you can see, Azure login, it will be used to log into your Azure account, and then a GitHub secrets, yes, then this will be run. The same script we run here, will be run, though you might not need to include your resource group and workspace names. This is already logged in, but because it is not set as default, so in using the Azure CLI or the Cloud Shell, you can actually set default workspace or default resource group. But then, since you might be working, you might at all times, you might not always be working with this is fine to set. But if you want to make use of another resource group or workspace, you just need to include it as an input parameter in your syntax while running that command. So we successfully edited this, and you will see there was a disclaimer giving why I highly recommend this learning path. There was a disclaimer given where it says they want you to use your intuition. So let's say each exercise is designed to allow you to explore how to implement this when working on machine learning. So some instructions may be intentionally vague, inviting you to think about your own preferred approach. So it was an amazing um, experience working with these learning paths, running down to triggering GitHub actions with trunk-based development. So trunk-based development is just your normal pull request, push, and all those things. So, like I explained here, having triggering a machine learning workflow, like running that model with when you make a pull request. And for example, now this one was carrying out a linting test and Py unit tests with using PyTest. Let me show you an example of what that did in this. I think this should be on pull requests. Okay, automatically by pushing. No, pull request. Okay, so carrying out, which one carried out the linting? So there's some that are used to carry out the linting that automatically trigger your GitHub action by creating a pull request. Okay. Okay. So for example, we had just edited to something very little in this, and then it completed everything. It checked it checked the script to check for other things. You could actually go to that particular branch where the pull request was uh, was made, and this one is closed. Is closed already. So let's check the pull requests that were closed. So we can see that it will have checked everything, just referencing this that was checked. So it's completed. It will check all the when what linting test or okay, let's start with linting. It checks the syntax and other things like how you write and some formats that you must strictly obey and all that. And then unit testing is carrying out some tests, like actual tests if the code works the way it's meant to work. So this was all done. This was all done using practicing with this branch. I just want to show us an example. Okay, so for linting, it checks to run the linting test and check using SR's Flick 8. You can make some research on that, and then also the unit test on it. The tests were already uh, predefined and run using PyTest. So yeah, moving on to challenge 4, we had working with linting and unit testing. This was still part of using the pull request to trigger this test, and then working with environments where we had to work with the production environment and the development environment, because in actual sense you would not want to deploy code straight directly into production. You might want to work with development or experiment environment and then move to the production environment to effect changes in terms of changes that could actually affect the code base. That's why most times we work with branches, right? So you create a branch and then you want to like merge the branch back into the main, then that can be done. So this is just like an example of how environments work. And then even each environment will have to have its own, because you could actually use the same Azure resource or workspace, but then you could, like standard, you might use different workspaces, and then each workspace will have its own login credentials, and these login credentials will be set individually for the environment. So, and then moving on to the final challenge, which was to deploy the model, we still made use of GitHub Actions to complete this, and then using GitHub Actions like we have here. This was the last one. Check from here, deploy model, and then this was done also manually, right? This was done also manually. We logged in, and then this is the syntax. Use the YAML syntax to deploy the model. So we did this in a way that create the endpoints, you need to have created the endpoint first before you can deploy the model to the endpoint. So this creates the endpoint, and this needs here does shows that if the endpoint has not been created, then the model cannot be deployed yet. So this one has to be committed successfully. That's why you can see an SS at some point for it to check the logs of the I think that was in okay, maybe trigger and push was not in this syntax, but for you to display the logs of one completed um, job before it can move to the other one so you can like successfully a string in this one. This was when you wanted to push the workflow, right, to trigger a workflow when the code has been pushed. So this basically does you could actually use any of these. They represent the same thing. So one dash s or double dash string to the logs of everything, whether it's successful and everything. And this init.experiment checks the logs to see if it has been successful before the production train job is run. So moving back to deploying our model, we logged in, and this was the syntax that was used to deploy the model. And all traffic means that the endpoint, all the traffic is deployed to one endpoint. So you could decide to create more than one endpoint or three endpoints and share the traffic to these ones however you want to share them. But we creating one endpoint, and we're deploying all the traffic to that endpoint. So we can see this here, where the model we have the model, and then the model has been registered to an endpoint. Model has been registered to an endpoint. So this is the diabetes reproduction prediction, not the development environment. I'm not using development environment. So with this, one thing about Azure Machine Learning Studio is that once you've deployed the model, it actually generates the API for you to use. So you have a test. You can test out the values from your data set. So you can decide to have we already had some sample test values here, so we could use this to check. Yes, we could use this to check, and just you see how your model works with predicting the value. So this is one as positive. So then the API endpoint is also given here. You have your primary key and other things. You have different syntax. So if you work with Python, you have the syntax already that will be used to deploy or to interact with the model's API, and then you could monitor how the API is being used, or deployment, or traffic and all that. So yes, this is the end, and this was triggered also with GitHub Actions, and this is where it was triggered from. Yeah, so this was a success, deploying the model. You can see the link here which shows that one depended on the other. So one deploy model job depending on the create endpoint job, and that's the summary of this um, learning path, and I highly recommend it. Thank you.